Hello, my name is Richard. I am a systems developer. I've mostly been working on Linux kernel testing the last few years, but I've also been doing some full stack development. I created a web app called Debug, and I've created another web app called Gripe, which I'm going to show you today. This is about a week's worth of work, which is something to bear in mind. And the motivation behind this is to do some experimentation with AI, with the new AI technologies that are now available, and also to scratch a personal itch, which is to create an introspective system where you can very quickly enter data and use that to analyze where you're losing time and what's causing you the most grief. Right, so let's get into the application. This is Gripe. It's live now on the internet at gripe.sh. You can try it out, although I don't make any claims that it's presently reliable. And the idea is that you can very quickly enter an issue, which, unlike most issue tracking systems, we don't care about duplicating tickets or anything like that. And when you want to enter a new ticket or when you want to search, it's exactly the same action. You just start typing. So let's say we want to either search for or enter a new gripe. We can just start speaking. It's difficult to remember what I'm supposed to say. Yeah, so here we go. Yeah, can upvote that ticket. But we could also add a new gripe as well. It takes a long time to add them because of the image generation. The AI generates an image based on what you're saying. Okay, and it's created that. I will point out that the idea behind the images, as well as just trying the image generation API, the idea behind them is as a way to quickly visually identify a gripe from the top of the list. So if you search for something like, I don't know, it's difficult to keep coming up with new gripes to search for on the cuff. So it's currently transcribing that and then it will search for it. Sometimes transcribing does take a little time. I'm not sure why, because it's often very quick as well. Okay, and then from the list, maybe we can quickly identify what it is we want just from the picture. But there's some issues with the images, as you can see. So yeah, I might get rid of those, but it's interesting to see how that works. And yes, that's Gripe. And eventually, the idea is that you'll also be able to use the AI to categorize the gripes. So when we're entering gripes, we don't need to worry about what category or tags to add, because the AI can do that automatically. It's something I've seen people do, and I'm sure it's quite easy using the OpenAI API. And also there's slightly more complicated things, like let's say you want to query the gripes and not only rank them by the upvotes, but also restrict the gripes to only the ones that say have the word database in or are tagged with database. You could train ChatGPT to produce the query that would do that. Currently, when there's no text entered, it just shows the gripes ranked by the number of points. So you can do more complicated queries, but I haven't had time to implement that yet. So then, yeah, and there's other features that could be added as well, such as exporting the gripes to a full-fledged issue tracking system, deleting them, removing the points, that sort of thing, or posting comments on them. Maybe if a particular gripe gets solved somehow, there's a workaround, you could sort of add that as an answer to it. You could import data from, say, Stack Overflow or Quora, whatever, with answers that it could automatically pick out. There's all kinds of stuff you can do, and we can do that using the transformers feature extraction from OpenAI and with a vector database. The vector database I'm using is Weaviate. So on that note, I'm going to get a bit more technical now and show you the database, the code. I'm using Go on the back end, which I've not used before, so this was an opportunity to try out Go. I've been quite impressed with projects written in Go in general. Like, you can just clone them and build them, and they often just work, which is not the experience with a lot of the C code and C++ stuff that I've been used to. But with Go, it's always been quite well done. And I'd say that Go is a pretty easy language to learn and pick up. That's probably why it's popular. And yeah, I'm compiling this to a static executable. It generally just seems to work, and I can put that in a container from scratch and deploy it on fly.io, and it's just, works pretty well. Yeah, currently the application is running on fly.io. I've deployed Weaviate to Fly as well, and it was reasonably easy to get that going, although it's currently not a highly available setup, so it would take considerable more time to deploy it with full redundancy and everything. But there we go. So this is the main entry point of the application. I'm using a Go web framework called Gin. You add roots and middleware in the usual way that you would with most lightweight web frameworks. As I said, I'm using Weaviate as the database, which is specialized in vector search, but it can do it is pretty much a general purpose database as well. I'm not sure it's a good idea to use it that way, but currently that's how I'm using it, just to keep things simple. I did look at adding another database, especially because you can create schemas in Weaviate. You don't have to, but you can. But then once you've created it, it's difficult to update it, and often I end up having to delete the database, which is why I've got this gripe here. I have to delete the whole database just to make some changes to the schema or how I'm doing things. It's a vector database, which means that you have to turn your text into a vector, or your images into a vector, and then it can, once it's got a vector, it can do a search on that. And I use the OpenAI plugin for Weaviate to turn the text into a vector, which can be used for search. So basically the AI model, the Ada AI model, is being used to turn it into a list of numbers, which we can do clustering and searches on, rather than trying to interpret the gripes as pure text, which you would in a more classical search algorithm. Weaviate can do like classic full text search as well. It can do some sort of keyword search. I've not tried using it, but it's just a case of enabling that. You can also enable hybrid search. So I think something to point out is that when we do a search here, the the search results, the text of the result may be completely different to what you've typed in, but the meanings of what you've typed in and what is displayed may be similar. So if we try and think of another way of saying something, yeah, it's come up with gripes can't be deleted, even though there's no, apart from the word can't, there's no crossover between those. In fact, yeah, even if we just have remove stuff, it still comes up with gripes can't be deleted as the number one thing, because semantically those things are quite similar. Which is what's really cool about vector search, and what would also make an application like Gripe a lot more feasible, because you don't need to worry about whether the keywords you're entering are stuff you've used before. You can just go ahead, enter something, and probably you'll get the result you want. You also get some confusing results, like remove stuff somehow also matches with images don't make sense, which, obviously there's quite a bit of difference in those two statements, but it's just struggling to find something similar at that point. Okay, so this here is the code which creates the database schema, sets up the database. The actual query code is in here. It's very verbose. This root here, this gin root here, this is what is called when we're just trying to get a list of top results. So if we delete that, right, so when we get this ranking just here, this is what's being called, this get gripes top. And yeah, if this were an SQL query, this would be probably just one line. Like, all we're doing is selecting all the gripes and sorting them and limiting them to 5, but instead we get quite a verbose Go statement. I think that's just the combination of the Go programming language and GraphQL. We're building a GraphQL query here, but it was quite simple to write and understand. And then we have a slightly more interesting query, which is where we do the actual vector search based on what we've typed in. We don't need to worry about calling the OpenAI API here, because Weaviate does it for us. We just need to set up the query, which means specifying what fields we want in the data output, and specifying a filter to make sure that we only return gripes for the currently logged in user. I would like to make it so users can share gripes and you can have groups and whatever, but that all takes more time. So currently you can just view your own gripes and there's no way to filter them or put them into groups, anything like that. Again, the idea is kind of as well that you shouldn't have to start making groups and things like that. That can be left to later and let the AI somehow figure it out. Okay, and then there's some code here to increment the gripes when you upvote them, and to post a new gripe, and here are the routes that are called by the JavaScript front end, which we'll come to the front end in a minute. Okay, let's take a look at the image generation. It's very simple. Here we're calling OpenAI using a library. Yeah, that's it. You just specify the prompt text which is used to describe the image, and then it returns the image as base64 encoded JSON, and I just put that straight into the database and serve it with each of the gripes. That's probably not the best way to do it, but then I don't know how much longer this image feature will survive anyway. So yes, that's all very easy to do. You can add that to an application in minutes. The hard part is actually getting the images to make sense, which you can do by prefixing the prompt with more text. I experimented with prefixing the prompt with oil and canvas, and it produced lots of images that looked like oil and canvas, so at least I got a theme going there. Anyway, so now let's look at the audio transcribing. Yeah, I'll point out that in Chrome at least, and on a lot of mobile devices, you already have audio transcribing built into the device, so we don't really need to do this ourselves and call OpenAI. I will say that OpenAI's transcribing feature works really well, and yeah, this route is a bit more complicated than some of the other routes, like the image generation route, but that's just because I'm handling a multi-part form which produces some kind of verbose code. But actually sending the recording to OpenAI is really simple. You just have a prompt again, and you just send the data that you've collected. Yeah, it's pretty simple. It'd be nice to see the transcribed text that has been produced so far in real time, but it will require a bit more code to get that to work, because the media recorder web API, which is being used on the front end, this is a Svelte file, by the way, if you've not seen it before. It's like a combination of JavaScript and HTML. And here we're calling the media recorder API, which is standard in web browsers. There's a quirk of this where chunks of audio don't appear to be independent. So if I want to send one chunk at a time and get the transcribing so far, I've got to join all of those chunks together on the server side and make them into a proper audio file, if what I just said made any sense whatsoever. Anyway, yeah, so that would take a bit more work to do, but otherwise this was pretty easy to get set up and working. Along with like most of the stuff really in this application, which you can see, I spent quite a lot of time actually just looking at Docker files and thinking about deployment and, you know, scaling it around the world and silly things like that. So I mean, the actual application itself, the code, the backend and the front end that you can see here, including things like the authentication, which I just copied and pasted from Auth0's quick start. All of this didn't take too long at all, really. Yeah, so to recap the architecture of the application, I've got a Go front end, which is using Weaviate as the database, which is my only database at the moment. If I was going to continue developing this, I'd strongly consider using something like NATS or like just a proper database like PostgreSQL, so that yeah, I don't have to rely on putting all of my data in Weaviate and then having a problem with the schema or some other issue, because Weaviate's quite a new database as far as I know. You probably don't want to use it as like your main source of truth, but it would be pretty cool to have a NATS object store where it can store things like images and the key value store, and then be able to propagate that data around the world if necessary, and then just use Weaviate to do the clever vector search and querying and stuff like that. Yeah, use Weaviate to do querying, build indexes, use NATS object store and key store just to store the data, and then repopulate Weaviate when necessary. Okay, and yes, it's using Svelte as the front end. Yeah, Svelte is awesome. I'm not much of a front-end developer, but I was very easily to get this set up using a Svelte library. I've forgotten what it's called. What's it called? Flowbite. Yeah, Flowbite, which uses TailwindCSS. The last app that I created, DoBook, I basically wrote everything from scratch. Didn't use anything like Flowbite. Just used Tailwind and Svelte on its own. And yeah, using Flowbite saved a lot of time. And yeah, and as you know, if there's something that Flowbite can't do, you can obviously just start replacing the Flowbite components with bespoke ones that you want to create. I also started using with this SvelteQuery, which helps synchronize data from the backend API with Svelte's reactive system. So if we go to the Gripes component, which currently this does all the querying. First of all, we have a query here that just checks whether or not we're actually online and whether we're logged in. And then we have the Gripes query, which fetches the Gripes, and basically SvelteQuery creates a query object which we can use reactively in a fairly simple way to either display like a message saying we're still loading data, or display the data, or display an error, which I currently don't really do. But anyway, yeah, display an error if something goes wrong pretty easily. This is again another sticking point with my last application where I was doing everything myself. Yeah, you start to discover that having asynchronous data flying back and forth, you need some sort of abstraction to handle that nicely, and SvelteQuery does. So there we go. Yeah, and you can see in the front end that you can just start doing stuff, and it all starts happening in the background. Nice asynchronous data. Okay, anything else that I've forgotten to talk about? No. As I said before, it's online. It's at gripe.sh. I also said that as a systems developer I have a website where I write a lot about my stuff that I'm doing. I have lots of articles on disparate topics like C and Zig. My most popular article is about Zig versus C and a more HTTP server. I've done a whole bunch of stuff. Yeah, and that's all. I hope you enjoyed it. Thanks for listening right to the end. Okay.